students. So in last lecture of the chapter motion in straight line, we have studied about the instantaneous velocity and we have solved the first kinematic equation. But in today's lecture also we are deriving first kinematic equation and another two kinematic equations also. These kinematic equations for the kinematic equations for uniform accelerated motion. These kinematic equations for the uniform accelerated motion. म्हणजेच काय तर फक्त आपल्याला हे जे पाहणार आहे तर ते युनिफॉर्म ऍक्सेलरेशन ज्यावेळेस युनिफॉर्म ऍक्सेलरेशन होते त्याच वेळेस आपल्याला हे जे मोशन इक्वेशन ऑफ मोशन आहेत तर ते त्याच वेळेस यूज करायचे. तर आपण हे तीन इक्वेशन डिराइव्ह करणार आहेत कशापासून तर ग्राफ पासून. बाय द ऑब्झर्वेशन फ्रॉम द ग्राफ डेटा वी आर डिराइविंग these three equation of motions and after that we will also derive these equations from the integration. Now from the starting, take graph first. We are taking a graph that is 0 to t with x-axis and this is y-axis, that is initial velocity v0 and final velocity v. All of we know that initial velocity denoted by the v0 and the final velocity denoted by the v. Now we know that what is the acceleration formula? Delta v by delta t. What is delta v? That is v2 minus v1 upon t2 minus t1. What is v2? v2 is final velocity and what is v1? That is initial velocity. We have the values v2 and v1. What is the final velocity? That is denoted by only v. And what is v1? That is the initial velocity, that is denoted by v0. Means v minus v0 divided by t2 minus t1. What is t2? t2 is t and t1 is initial value of time is 0. Therefore our equation is v minus v0 by t. A equals to v minus v0 by t. Now final equation is t. T is in division, therefore that is at. It is in multiplication now. V minus v0. Then what is final equation? At equals to this v0 will transfer here. That is minus, then it will be a plus. At plus v0 equals to v. What is the final equation? V equals to v0 plus at, and this is our equation number first, and this is our first kinematic equation for uniform accelerated motion. Now the second equation, that is x equals to v0 t plus 1 by 2 at square. X is a displacement. X is a displacement. v0 is initial velocity. I v initial velocity. T is the time. A is the acceleration. And t is known as time. तर विद्यार्थी मित्रांनो आपल्याला इथे काय करायचंय तर डिस्प्लेसमेंट, व्हेलॉसिटी, ऍक्सेलरेशन याच्या बद्दलचं जे काही रिलेशन आहे ते आपण या इक्वेशन वरून आपण काय करणार आहे डिराइव्ह करणार आहे. इज इट ओके? नाउ हाऊ वी कॅन डिराइव्ह दिस? दिस इज फ्रॉम द ग्राफ. We take the first graph. Now this is the velocity, initial velocity v0, final velocity v. Suppose this. Now this is the time instant, that is 0 to t. This is y-axis. Now we have to calculate the area under the curve, this curve, area under this curve. Now we can derive it, we can calculate as this one is triangle, and now this one is रेक्टँगल. तर काय विद्यार्थी मित्रांनो, आता आपण याला दोन पार्ट मध्ये डिवाइड केले, एक हा त्रिकोण आणि दुसरा आयत. तर आता या फिगर वरून आपल्याला काय करायचे, हे इक्वेशन जे सेकंड इक्वेशन ऑफ मोशन आहे ते आपल्याला डिराइव्ह करायचे. तर ही जी हाईट आहे, तर ही हाईट कशी कॅल्क्युलेट होईल, v v नॉट, कारण इथपर्यंतचा जो काही व्हॅल्यू असेल ती v नॉट आहे, हा v आहे. v v नॉट जर कॅल्क्युलेट केलं तर काय आपल्याला मधला जो डिफरन्स आहे तो डिफरन्स भेटेल, म्हणून ही हाईटला आपण काय केलं, v v नॉट. नाउ एरिया अंडर द कर्व at instant between 0 to t, at instant between 0 to t, area under the curve, area under the curve at instant of 0 to t equals to, now I kept here, that is equals to area of triangle. Now we will give the names A, B, C, D, and this is O. Area of triangle. What is the area of triangle? That is triangle ABC plus area of rectangle. Area of rectangle. What is this? OACD. Then what is the formula of area of triangle? That is 1 by 2 L into B or H. You can take anything. And what is the area of rectangle? That is simple, L into B. Now 1 by 2 L into B. B base, that is the 0 or T. That means 1 is T and base is T, and the height, that is v minus v naught. V minus v naught into T plus, now this is the value of v naught and this base is T, v naught into T. Now our equation is 1 by 2 v minus v naught into T plus v naught T. Now we know the value, v minus v naught from the here. V minus v naught is equals to 80. Now we can write as v minus v naught instead of 80, and this T is as it is, plus v naught T. Now 1 by 2 8t square plus v naught T, that is equals to x, and this is our equation number 2. Now we have derived the equation number 2. Now last equation number 3. We can derive this equation from both first two equations, first and second equation. Before that, we have to write this equation 1 by 2 v minus v naught T plus v naught T. How we can write this equation? Now we will write here first x equals to 1 by 2 v minus v naught into T plus v naught T. How we can write it as 1 by 2 Vt minus 1 by 2 V naught T plus V naught T. Now you can calculate it, and we got the answer as V plus V naught by 2 into T. Now that is equals to x. Now put the value of T. Now put the value of t from this equation. Now what is what is the value of t? T equals to v minus v naught by a. What is the value? T equals to v minus v naught by a. Now you can put this value here. Now x equals to v plus v naught by 2. Instead of t, we will put the value v minus v naught by a. Now we will get the value as v square minus v naught square divided by 2a. That is x equals to v square minus v naught square by 2a. Now transfer here. Now that is 2ax equals to v square minus v naught square. Now what is the v square then? Take here v naught. 2ax plus v naught square equals to v square. Then v square equals to v naught square plus 2ax. And this is our equation number 3rd. And now we have solved these 3 equations of motion for the uniform accelerated motion from the graph. Okay, so thank you for watching this video.